Hi ladies, in this video we're going to go through exact values and radians, so introduce you to radians. So basically with circular functions or the unit circle, we tend to shift away from using degrees and move into radians. And you would have heard of radians before because I've warned you about your calculator being in radian settings when we were doing trig, and I said it should be in degree mode. But when we move into circular functions, you will be working in radians. So just make sure that your calculator is in the correct setting. But for this section, we're not really doing anything on the calculator anyway. We're just looking at exact values and also how degrees and radians relate to each other. So kind of think of it as, we can measure weight in grams or pounds. Okay, so it's just radians and degrees are just another way of measuring an angle. Now, what we've got here in the key ideas, I might just get my highlighter up. A radian, here we go, 1 radian, is we use the symbol like the little C up the top to show that it's a radian. And obviously, the degree sign. So if you're wondering what that symbol is, that's just saying it's a degree. Now, if we think about a whole circle going around 360 degrees, that is equal to 2 pi radians. Okay, so basically we have a radius of 1 for our circle. So if we're going around, it's going to be 2 pi r, the circumference of the circle. So it's just 2 pi times 1, which is 2 pi. Okay, so on your circle, I've already done this for you previously. So I'm just writing the degrees in. And I should probably put the degree symbol on. So I'll go back and do all that. And we'll have go back to 360. Now, in your in radians, we also start at 0, but a full circle is 2 pi. Okay, so that is shown here. 360 is equal to 2 pi radians. So if we were to go halfway to 180, we've gone pi. And then at 90 degrees, we've only gone halfway, so it's pi on 2. And then at 270, we've gone 1.5. So it's going to be 2 pi on 3. So you can see those values here. So 90 degrees is pi on 2, 180 is pi. And then you've got some others. So 60 degrees is the same as pi on 3, 45 degrees is pi on 4, and 30 degrees is pi on 6. So you can get those values as well by using this conversion. Okay, so this is extremely important to know. So how to convert degrees into radians. So you can use this little diagram here. So if you're going from degrees to radians, you multiply by pi over 180. And if you're going from radians to degrees, you multiply by 180 over pi. Okay, so just using this probably a lot in this section. Oh, look at me colouring in. I get a little bit carried away. Okay, so that is extremely important if you wanted to highlight it like I just have. All right, so that's basically converting from degrees to radians. Now, the exact values, now this looks a little bit more complicated than what it actually is. This first triangle here, it's an isosceles triangle, so we've got 45 degrees for each. Now remember our unit circle, so I might just draw this triangle in our unit circle. Let me just think about how it would go. All right, so I just drew it. Sorry, I had to pause it to get my head around it. So here I've got the triangle. So there's our 45 degrees in there. So you can see the opposite and the hypotenuse, the opposite and the adjacent side. So here we got the adjacent and the opposite, and here's the hypotenuse. So you can use your knowledge of trig ratios to get this triangle here. Or you could use Pythagoras' theorem. Okay, so if you're wondering how we get 1 and 1, so that's just the radius of your circle. And then the root 2 you can get from Pythagoras' theorem. Now, sine theta, remember, is opposite over hypotenuse. So in this triangle, our hypotenuse is root 2, and your opposite is 1, and your adjacent is also 1. So that's how we get 1 over root 2. Now, if you're wondering why it's then written as root 2 over 2, that's because we've rationalized the denominator. So usually we don't leave a surd in the denominator. So multiplying by root 2 over root 2 gives you root 2 over 2. Then you've got cos, which is adjacent over hypotenuse. Okay, so that's the same. So 1 over root 2. And then tan, which is opposite over adjacent, which is 1 over 1. So that's how you get your exact values. The second triangle, which we have here, okay, so we've got 30 degrees and 60 degrees. Now, if we were to draw that inside our unit circle, so let me just redraw it. Oops, trying to erase some things without erasing everything. So I'll put that line back in. Okay, so we have 30 degrees and it's kind of, whoops, no, probably should go out a little bit more than that. You don't need to draw this, but I'm just trying to show you. So it's kind of gone up like that in a way. Now we've got 1 here. Okay, so that's the same as this height, which is 1. And the root 3 and 2 you can get from using your trig ratios. Okay, so they're your exact values for a triangle with 30 degrees and 60 degrees. In this middle column, we're just looking at 30 degrees first. Okay, so we're just using this angle. So your triangle, we're going to have this labeled as your hypotenuse, this side labeled as your adjacent, and then your opposite. And you're using SOHCAHTOA again to get those values. For sine 60, we're now using 60 degrees. So I'm just going to get rid of that. And obviously your opposite and adjacent sides change. So this is now your adjacent and this is your opposite sides. And you use your trig ratios. So you've got 60 degrees there. Okay, so these values you can use to help you remember the exact values, but I'll show you a way to help you remember this table. Okay, so first of all, let's just have a look at what we've got shaded in yellow or orange, whatever color you want to call it. So first of all, we've got in the first column, we've got the degrees. So these are all your degrees, and then their associated length in radian. Okay, so 0 degrees is equal to 0 radians. 30 degrees is equal to pi on 6 radians. I might just get rid of that so we can see it a little bit better. 45 degrees, pi on 4 radians. 60, pi on 3 radians, and so on. Now, with these values in your table, if you have got it written this way, and sine, cos, and tan, what you can do to help you remember is, and I might just write sine, cos, whoops, and tan. All right, so I'm just rewriting these values and I'm showing you how to remember. So everything is a fraction over 2. And then for sine, we just start off with 0 and write 0, 1, 2, 3, 4. And then all those numerators we do the square root of. So the square root, square root, square root, square root, and the square root. Now, we just got to simplify them. So the square root of 0 on 2 is 0. And you can see that's what we get here. The square root of 1 is just 1. So we have 1 over 2, which is equal to a half. Root 2 on 2, we can't simplify, so it just stays as root 2 on 2, which is what we've got here. Root 3 on 2, we also can't simplify, so we'll leave that there. So root 3 on 2. And then the square root of 4 is 2, so we have 2 on 2, which is equal to 1. Okay, so just what I did there can help you remember your exact values. And we're going to do this again in a second. All right, we do the same for cos. So we put them all over 2. But this time, instead of going 0 to 4, we go backwards. So we go from 4 down to 0. And we'd also take the square root. All right, so basically you're going to end up with the same thing. It's just the reverse, okay? So the square root of 4 on 2, 2 on 2, which is 1, which we get here. Root 3 on 2, okay, so that doesn't simplify. Root 2 on 2. Root 1 is 1, so half, and then root 0 is 0, so then we've got the 0. Now tan. Remember tan, and I might just have to write this over here, tan is equal to sine on cos. So you can just take your values of sine and cos. So sine for 0 degrees is 0, and for cos is 1. So 0 over 1 is 0, which is what we've got there. The next one now, this is going to be quite complicated because you're going to have to use your knowledge of fractions. So we've got a half. Now it's over, but because I've got a fraction, I'm going to divide it. Half divided by 3, root 3 on 2. When we're dividing a fraction by a fraction, we keep the first, change the sign, and then flip the second. So those 2's cancel out, and we're left with 1 on root 3, which is, where did I go wrong? Oh, sorry, didn't go wrong anywhere. 1 on root 3 is the same as root 3 on 3, but it just rationalize the denominator. So when you have a third in your denominator, just multiply it by root 3 over root 3. Whoops. And then you're left with root 3 on 3. So that's how we get root 3 on 3 there. All right. I haven't given myself much room to write. Then we've got root 2 divided by root 2 on root 2. Sorry, root 2 on 2 divided by root 2 on 2. So when you're dividing the same number by itself, it just becomes 1. All right, then the next one, we've got root 3 on 2 divided by a half. So that's the same as root 3 on 2 times 2 on 1. So your 2's cancel, and we're left with root 3 on 1, which is just root 3, which is what we've got here. And then the last one, we've got 1 divided by 0. You can't divide anything by 0, and that's why it's undefined. Okay, so you can use that system to help you remember what your exact values are. So we're going to do the same thing here in building understanding. So I'm going to fill this in, and then in a second video, we're going to do the questions, just because I don't want the video to be too long. All right, so when we're looking at converting degrees into radians, 360 is the same as 2 pi radian. Okay, and pi is equal to 180. 90 degrees, if you think about it, is 1/4 of 360. So that's 1/4 of 2 pi, or half of pi, so pi on 2. Pi on 3, okay, if you wanted to convert that back, say what do I need to do to get that to pi? So I multiply it by 3. So I'm going to divide 180 by 3, so that's 60 degrees. 45 is pi on 4. Because I'm actually doing in my head using, sorry, I probably should have referred to this a bit more. What I've just highlighted here in green is exactly what I'm doing in my head. So if you're going from degrees to radians, you multiply by pi on 180, radians to degrees times by 180 on pi. All right, pi radian on 6 is 30 degrees. And then 15 is going to be pi radian on 12. No, hold on. All right, sorry, it is pi on 12. I just had to check that. Okay, state the missing fraction. So to convert from degrees to radians, we multiply by, so let's go back to where I highlighted all in green. Degrees to radians, we multiply by pi on 180. And then to convert from radians to degrees, we just do the opposite, so 180 over pi. So you can use that to complete the table above. All right, so number 3, use trigonometric ratios, so SOHCAHTOA with these triangles to state the exact value. So I'm not going to do them all because we just don't have enough room, but I'm just going to show you how to do it. So if we were doing sine 45, so remember sine theta equals opposite over hypotenuse. So we've got sine 45. Your opposite side is 1, and then we've got root 2. Now, what you need to do is just rationalize the denominator, because we don't usually leave a third as a denominator, so multiply it by root 2 on 2. So that gives you, sorry, root 2 on root 2 gives you root 2 on 2. If we were to do, let me choose a different one. Let's do tan 60. So tan is opposite over adjacent. So if we're looking at 60 degrees being our angle, your opposite side is root 3 and your adjacent side is 1. So we're going to have root 3 over 1, which is equal to root 3. All right, so see if you can finish the rest of number 3. The answers are in your textbook. All right, lastly, with this table, so it's exactly the same table as quite similar to what we did here. All right, so let's see if we can remember. The only difference is we've added in 180, 270, and 360. So I'll see if I'll show you how to do that in a second. All right, so we've got all our degrees in. Let's put our radians. So 0 degrees is equal to 0 radians. 30 degrees is pi on 6. 45 is pi on 4. 60 is pi on 3. Should put my radians in. 90 is pi on 2. 180 is pi. 270 is 3 pi on 2. And 360 is 2 pi. All right, so this is where we can use what we did before. All right, so that little trick we can use here. So remember, the first thing you need to do is everything is over 2. And I'll just do to 90 because I'll talk about 180, 270, and 360 separately. All right, we start off with 0, and then 1, 2, 3, 4, and then we just take the square root. So much space here to do this. And then just simplify. So root 0 on 2 is 0. Root 1 on 2 just is half. root 2 on 2 just stays root 2 on 2. Root 3 on 2 just stays root 3 on 2. Probably didn't need to write that again. And the square root of 4 is 2. So we've got 2 on 2, which just gives you 1. Now, cos theta is the opposite of all that. So I don't need to go and do, write my 2's and then the 0 to 4 and then the square root. So we're going to start off with 1 and then root 3 on 2, root 2 on 2, then a half, then 0. Now, tan theta, it's a bit easier when it's written this way than what it was before because we can easily see sine on cos. So 0 on 1 is 0. A half on root 3 on 2. What was that? Root 3 on 3. Then we've got root 2 on 2 on root 2 on 2 is 1. It's going to be root 3. And 1 on 0 is undefined. Now, for the rest of them, the 180, 270, and 360, I'm just going to draw a unit circle over here. So this is 0. You can write it in radians or degrees. I might start writing in radians because that's what we're going to be using mostly. Now, remember that sine is your y and cos is your x. So if we're at 180 or pi, which is here, your x coordinate is -1, which is cos, and your y is 0. And then we can also do tan, so 0 divided by -1 is just 0. All right, 270, we're down here with 3 pi on 2. So when we're here, x is 0, so cos is 0. Sine, being your y, is -1, and -1 over 0 is undefined. And then lastly, 360 is the same as 0, okay, because you're at the same spot, so you can just write that down. So 0, 1, 0. Okay, so you should know all the points here. So 0, 90, 180, 270, 360. The 30, 45, and 60, you will probably remember because you'll do them so many times. But if you forget, you can quickly write them down like I have. It doesn't actually take that long to do. All right, so girls, I'm going to leave this video here because I want to keep them around 20 minutes. So in the next video, we'll be doing the questions. Just maybe go back and do question 3. All right, so doing the exact values with them using those 2 triangles.